This is the homework helper for page 191 in the 8th grade textbook, Simplifying Square Roots. We'll go ahead and take a look at the first 4 questions here. The first 4 questions on that page are asking me to simplify, which implies that they're asking me to write that in simplest radical form. As you can see, I've still got those same perfect square roots on the right side of my screen there, on the right side of my presentation, that represent the numbers that we want to be pulling out of or making a product with in that root, because those are the numbers that are actually going to simplify, and we'll be leaving some roots behind that. Those are the exact same numbers that were on the screen during the notes part of the presentation. So number 1 is asking me to work with the square root of 18. So when I'm working with 18, I want to use one of those numbers in that product. So the number that's obviously going to make most sense there is going to be 9. I can use 4, 9, or 16 because all of them are less than 18. But really, the only one that goes into 18 that would make any sense to write a product with would be 9. So the square root of 18 is the same as the square root of 9 times 2. Now again, we're going to separate those into 2 parts. So I'm going to rewrite this as the square root of 9 times the square root of 2. Well, the square root of 9 is a perfect square root. The square root of 9 is, of course, equal to 3. So I rewrite that as 3 and leave the root 2 behind because there's nothing I can do with root 2. And so the square root of 18 is the same as 3 root 2. Let's try that again. Number 2, the square root of 12. So I'm going to use one of those numbers to form a product that will make 12. Obviously, I've only got 2 choices here. 4 and 9 are the only 2 that are less than 12, so those are the only 2 that would make sense. 9 isn't going to go into 12 very easily, so 4 is obviously going to be the pick. Well, 4 times 3 makes 12, so it's really the square root of 4 times 3. Again, I'm going to separate those into 2 parts, and then I'm going to simplify the square root of 4 here. The square root of 4, as we know, is a perfect square root. That's equal to 2. Root 3 is going to left behind, so that's the same as 2 root 3. In number 3, we've got the square root of 200. Well, we've got a lot of choices here. We can use pretty much anything on the list. I'm actually going to use one that's not on the list, though, but one we talked about specifically in the notes section. When we go down the list, square root of 64 is 8, the square root of 81 is 9, the square root of 100, which is where I'm going here, is going to be equal to 10. So I want to use 100 here, and of course that means I'm going to partner 100 with 2, because 100 times 2 is going to give me 200. I'm going to separate those into 2 parts. So this is going to be the square root of 100 times the square root of 2. The square root of 100 does simplify. Square root of 100, as we said, is 10. Root 2 I can't do anything with. It's already fully simplified, so I'm going to leave that behind. And that's the same as 10 root 2, or 10 times root 2. And we'll practice one more with number 4 there. The square root of 128. You've got, again, a lot of different choices here. 4 would be an option for you. 16 would be an option for you. But I'm going to go ahead and go with 64. Because as I said in the note presentation, chances are the bigger number you pick, the less work it's going to be overall. So I'm going to rewrite this one as the square root of 64 times 2. Well, now I'll separate them and rewrite it as root 64 times root 2. The square root of 64, that's a perfect square root, so that's going to pop out as an 8. And I'm going to leave the root 2 behind, so that's 8 root 2. All right, let's go ahead and now look at a few questions in the middle section there. So we're going to go ahead and take a look at questions 13 and 14 now. But of course I need to erase what I have up here already, so we'll get rid of those. And we'll start with question number 13 there. Question 13 is talking about the square root of 27. And I'm supposed to subtract 3 root 3. Now, of course, 3 root 3, we're looking at that 3. We know the smallest number we're going to be able to pull out would be a 4. Since it's already less than 4, we know that this one probably isn't going to change. But the square root of 27, we can do some rewrites there. We know that this root is probably going to be a number that's going to be over here. What could I do with 27 as a product that involves a 3? Well, we know that 3 times 9 equals 27. So I want to rewrite this as 9 times 3. And then I'm going to separate it just like we did in the questions a minute ago. So it's the square root of 9 times the square root of 3. Well, the square root of 9 is a perfect square root. The square root of 9 is equal to 3. So this is really 3 root 3, and I'm subtracting this guy that I still haven't touched, which also says 3 root 3. So I've got 3 root 3's, and I'm taking away 3 root 3's, and as you can see, that question is going to go to 0. And we'll go ahead and take a look at question 14 now. Question 14 is the square root of 125 plus 4 root 5. Now again, this question is kind of leading because we know the smallest number we can take out is 4. The next number up on the list there is 9, but obviously this 5 that we already have is smaller than that. So 9 isn't going to work. The only number we could possibly take out of that would be 4, but we know 4 isn't going to come out of 5. So that means that that's already going to be fully simplified, which helps us know that probably one of the other numbers that's going to be over here is going to be a 5. So what can I do with a product that's going to involve 5 to make 125? Well, we know that 5 times 25 is 125. So let's write it that way, 25 times 5. We'll separate it, so we'll write it as the square root of 25 times the square root of 5. Well, the square root of 25 is equal to 5, so that's the same as 5 root 5. And then I'm going to drag that guy down and do what it says, which is to add. So I've got 5 root 5's, and I'm going to add 4 more root 5's. Well, if I have 5 root 5's and I add 4 more root 5's, I end up with 9 root 5's. So the square root of 125 plus 4 root 5 must make 9 root 5. All right, now let's look at one more. We're going to go ahead and take a look at this question 17, which says 5 root 12 is the square root of what number? So let me go ahead and erase this one, and we'll start figuring this one out. Let's take a simpler question to start off with here when we're looking at number 17. Let's take a question like the square root of 8. If we were doing simplest radical form with the square root of 8, what would you do? Well, of course with 8, the only number that you could really work with on this list would be 4. So you would rewrite this as root 4 times 2, and then you'd separate them and simplify the root 4 part into 2 root 2. Well, what happened here that's the relationship between the 2 and the 4 that's underneath the root there? Well, obviously, if I double this guy, that's how I get back to 4. Let's make sure that's not a fluke and try it with another question. Let's try the square root of 27. All right, well, if we're talking about 27, we've only got these choices for numbers that would come out of 27, and the only one that makes any sense would be 9. 4 doesn't go into 27 evenly, 16 doesn't go into 27 evenly, 25 doesn't go into 27 evenly, but 9 will. So this is going to be the same as 9 times 3. When I separate them, I write root 9 times root 3, the square root of 9 here. All right, that's going to give me 3, so I got 3 root 3. Well, it's not double this time, but what is it? It's actually 3 to 9 would be squaring it. All right, just like 2 to 4 would also actually be squaring it. So we see that the relationship when we practice a few times is actually squares. And that should make sense to us. Why? Because squares and square roots are opposites of each other. So when I square this number that's on the outside, I get the number that was in the inside. Whether we showed it here or here, it works both ways. And you can test it with other numbers, but you'll see that that's actually what happens. So now let's actually look at question number 17. It says 5 times the square root of 12. Well, We know when this was under the root then, it had to have been 25. Because as we showed here, when I take the number that was out and square it, I get the number that it was underneath the root. So underneath the root, that must have been the square root of 25. And then, of course, this guy would have still been there too. Well, all we're doing is we're going in the opposite direction here. So if I recombine this, this is really root 25 times 12. Well, what's the square root, what is 25 times 12 there? And again, it's going to stay under the root. 25 times 12 is, of course, 300. So this, to answer the question, must have started off as the square root of 300.